Welcome, everyone. Today we'll explore PADAS, a powerful platform built on Confluent that enhances security operations through real-time data transformation, filtering, enrichment, detection, and aggregation. Let's dive in. Here's what we'll cover today. First, we'll discuss what PADAS is and how it can benefit your security infrastructure. Then, we'll go over the value proposition and the challenges PADAS addresses. We'll explore the architecture and core functionality. After that, I'll walk you through the setup and configuration of our demo. Finally, we'll wrap up with the next steps you can take to explore further. PADAS is built on the robust Confluent platform as a streaming application specifically designed for real-time data transformation, filtering, and detection. It is a scalable augmentation solution for your existing SIEM systems by processing massive amounts of data without adding any additional load. What's more, PADAS is incredibly flexible and customizable, allowing you to integrate custom detection rules via PDL, PADAS domain language, all while remaining independent of your existing SIEM. This makes it a cost-effective solution for offloading critical data processing tasks from expensive SIEM resources. Let's talk about the challenges with traditional SIEM systems and how PADAS can help. Many SIEM systems struggle to handle the massive data volumes of large organizations. PADAS, using Confluent's streaming platform, processes trillions of messages daily in real time, so you get speed and performance at any scale. Integrating data from various sources can be a headache. PADAS automates this, making it easy to connect and transform data from platforms like Splunk, Elasticsearch, Syslog, AWS, and more. This saves time and ensures accurate threat detection. Traditional systems can be slow with alerts, delaying your response to threats. PADAS delivers real-time detection, so you can act immediately when something's wrong. SIEM tools can be pricey and lock you into their ecosystem. PADAS optimizes costs and integrates with multiple SIEMs, giving you freedom and flexibility. In short, PADAS is a powerful, flexible, and cost-effective way to enhance your SIEM system and improve your threat detection. Here's an overview of the PADAS architecture. Data from various sources, such as OS events, network devices, firewalls, and application logs, is ingested into the Confluent platform. PADAS reads from specific Kafka topics, processes the data through any number of pipelines that can perform transformation, filtering, enrichment, detection, and aggregation, and then writes the results to output topics. These output topics are then consumed by endpoint SIEM systems like Splunk or Elastic, enhancing their analytical capabilities without overloading them. Let's break down the internal functionality of PADAS. PADAS uses a topology, which is a group of ordered pipelines, to read from a single input topic and write to one or more output topics. Each pipeline is composed of ordered tasks, where the output of one task feeds into the next. A task is the smallest unit of work within the pipeline, responsible for handling specific operations on the streaming event data. A task comes with built-in functions like apply rules, extract, filter, output field, and more. These functions make it easy to parse, filter, and transform your data. Finally, rules are PDL expressions or correlations used for query matching and aggregations. These can be annotated with relevant content, such as MITRE ATT&CK technique IDs. We also have a conversion tool for Sigma rules to PDL for easy integration. Now, let's move on to the demo setup. In this demonstration, we'll be working with sample Palo Alto firewall logs. We're simulating event generation using a sample event producer. There are two key topologies in this demo. First, we have Palo Alto filter topology. This topology transforms and filters events reading from the topic named Palo Alto input and writing to the topic named Palo Alto filtered output. The second topology is named Palo Alto detect topology. This topology runs detection and aggregation rules against the filtered events, generating alerts. It reads from the Palo Alto filtered output topic and writes to the Palo Alto alerts output topic. Here's a closer look at how the demo is configured. In the Palo Alto filter topology, we read from the Palo Alto input topic and run a pipeline that transforms and filters syslog data, specifically focusing on DNS events. This topology has 4 tasks defined. The Palo Alto extract task removes the syslog header. The Palo Alto output task outputs the extracted value as new event data. The Palo Alto Parse CSV task applies a CSV parser for field extraction. The Palo Alto filter task drops allow DNS events, ensuring only relevant data is passed along. In the Palo Alto detect topology, we read from the Palo Alto filtered output topic and run a pipeline focused on security rule enforcement. This topology has only one task for applying rules. The Palo Alto apply rules task applies selected detection rules to the streaming event data, generating alerts based on conditions like multiple failed login attempts and unusual port activity. First, we'll view the user interface and initial topic contents. Here we have the PADAS user interface. Let's start by exploring a sample input topic, where we used a script as a producer to generate Palo Alto firewall events. To view these events, we'll configure the timeout and set the offset to the earliest point. The events generated by Palo Alto are delivered as syslog messages, which we can easily navigate through to examine in detail. This process can also be managed via Confluent Control Center, the user interface for the Confluent platform. Additionally, in production environments, we would typically use Confluent connectors to integrate data from various sources. Note that we see a lot of events for allowed DNS traffic, which we'd like to filter out. Next, we'll go through Palo Alto filter topology settings from the user interface and see it in action. In this section, we're looking at the tasks associated with the Palo Alto filter topology. The first task, Palo Alto extract task, removes the syslog header, retaining the raw event as a field. Next, we use the Palo Alto output task to output this raw event as the new event data. This output then serves as the input for the Palo Alto Parse CSV task, where a CSV parser is applied to extract fields and convert the event into JSON format. After parsing, we apply the Palo Alto filter task, which filters out allowed DNS events via PDL query, ensuring only relevant data is passed along. If we examine the filter pipeline, we see these tasks laid out sequentially. First extracting the syslog header, then parsing the CSV, and finally applying the filter function. The topology configuration defines the input topic, reading from the Palo Alto input, and writes to a single output topic named Palo Alto filtered output. The pipeline, named Palo Alto filtered pipeline, consists of all four tasks, and the topology is enabled. Finally, as we view the contents of the Palo Alto filtered output topic, you'll notice that no allowed DNS traffic appears, confirming that the filtering is working as intended. We can scroll through the events, and whereas DNS traffic was previously visible, it's now completely filtered out. Let's go through Palo Alto detect topology settings from the user interface and see it in action. Let's start by exploring the rule configuration for detection purposes. We've set up a rule that uses a PDL query to filter events, specifically targeting failed authentication attempts. The PDL query aggregates these events by source address and user, and it triggers an alert when the aggregated event count exceeds a threshold of 1. You can also add annotations to this rule for additional context. To apply this rule, we use an apply rules task, which can handle one or more rules. We can select to match all rules or stop at the first match within the function definition. This task is incorporated into a pipeline. And this pipeline is used within a topology. For this demo, we're using a simple setup, but the apply rules task can be integrated into a more complex topology with multiple tasks and pipelines, similar to the one we discussed earlier. In this case, within the Palo Alto detect topology, we read from the Palo Alto filtered output topic and run a pipeline focused on security rule enforcement. This topology contains a single task, the Palo Alto apply rules task, which applies the selected detection rules to the streaming event data. This task generates alerts based on conditions such as multiple failed login attempts. Finally, if we check the Palo Alto alerts output topic, we can see the alerts generated by the rule. These alerts are aggregated by source address and user, showing us the event count that has surpassed our defined threshold. Let's quickly recap. PADAS strengthens your SIEM by scaling to handle vast amounts of data in real time, ensuring both speed and efficiency by leveraging Confluent connectors. It seamlessly integrates data from diverse sources, streamlining transformation and improving threat detection. With real-time alerting, PADAS swiftly identifies threats, enabling immediate response. Its ability to integrate smoothly with various SIEM platforms, combined with efficient data pre-processing, delivers both cost reduction and flexibility. In the demo, we saw how PADAS effectively filters irrelevant data and detects security threats, making it easier for endpoint SIEM systems to consume and act on critical information. Thank you all for your time and attention today. If you'd like to learn more about PADAS or request a personalized demo, please visit our website or reach out to us directly. We're excited to help you enhance your security operations with PADAS, and we look forward to connecting with you soon.